Hey everyone, so this is my lab 5 for physics 1, and I did a maximally inelastic collision, and this experiment is just computational. So the purpose of this lab was to observe the motion, momentum, and kinetic energy of two masses as they collide inelastically. And so some of the models and fundamental physical principles I used are position update formula, conservation of momentum, and then kinetic energy. And so the main lab result of this lab was because the masses collide and stick together, the collision is maximally inelastic, which means that kinetic energy is not conserved, but momentum is conserved. And so some basic physics principles that I used, the momentum formula, so momentum equals mass times velocity. Kinetic energy and change in kinetic energy is 1/2 mv squared. And then just the position update formula. And so the system in this case are mass 1, mass 2, and the surroundings are the Earth. And then there, I just have the initial conditions. Both masses are the same mass, they're 0.1 kilogram. So in GlowScript, I create code up here, both masses are the same, 0.1 kilograms. The velocity of the yellow ball or yellow mass is 0.4, and then the mass or the velocity, I'm sorry, of the blue ball is 0.2 in the x direction. So the velocity is a vector, and then multiplied by the mass, I got the momentum. And then I calculated the kinetic energy of each ball before the collision and then both balls after. And then updated the position and updated the momentum in order to get the change in momentum over time, or to show the momentum over time. And then I plotted it as shown here. So this is the yellow ball and then the blue cyan ball. And the reason that it is kind of a spring sort of looking function is because I used a spring constant. So as they collide, they're together, they're still vibrating, which is why there's not just a singular line as the two collide and become like one mass. And so here are just, it shows the initial momentum was 0.6 in the x direction. 0.06, I'm sorry. And so the same as the final momentum, which shows that final momentum in general was conserved. But the kinetic energy was not conserved because in an inelastic collision, kinetic energy is not conserved. So some source of error, since this was a computational experiment only, mainly just human error on my part in turning like the physics concepts into code correctly, and just coding the graph. Like I went back to some of our past like Python GlowScript codes to figure out how to graph, but I may have not done it correctly. So that was the largest source of potential error. And then I create my own what if question. It's pretty basic, but mainly just checking for understanding. So what if the two masses collided and they broke apart? How would this change the conservation of momentum? Well, in this case, it would most likely still be inelastic because elastic collisions are highly unlikely. So momentum would still be conserved, but the two masses would have their own individual velocities instead of like a combined velocity as they become one mass. But kinetic energy would still not be conserved. So in conclusion, in maximally inelastic collisions, kinetic energy is not conserved, but momentum is conserved. And elastic collisions, on the other hand, they do involve the conservation of kinetic energy. That's it. Thank you.